In this video, we're going to be practicing working with scatter plots and dealing with the slope and the Y-intercept. Okay, first off, it says the scatter plot and the linear parent function are shown below. What should you do to the linear parent function to accurately represent the trend line of the data? Okay, if I went, and I'm going to see if I can make myself a line like this right here. This will help me. So this is how I'm starting, okay? What do I need to do to make this a good trend line? How can I make this go through the middle of all the points? First off, if I go and I move, let's see here. What if I went, and I'm going to put this back on here. Let's see if I can do that. Let's see here. There we go. What if I went and I just tried to move it up or down? Increase the slope, like I'm going to make the slope larger. Does this work? Is it really a good fit? Does it go through all of them? Or make it flatter? No, it doesn't really seem to work. What if I slid this up? Ooh, look. So if well, first off, let's back up a minute. To increase the slope, I would have to tilt it and make it steeper. That's not too bad, but I don't know that it's the best. So what about if I decrease the slope? I made it a smaller number and made it go down. Nope, it can't be D, so I would cross out D. Now, let's look at something, though. I just said that when I go and if I try and move my line up, right here I'm increasing the Y-intercept. Okay, so it's going to be this answer right here. That'll be the better answer. Right here, so it would be increase the Y-intercept. Next, on this one, same type of thing. What if I had a line? Let's see if I can put a line in here to match it up, and we can kind of play with it and see what happens. See, I know you don't have the computer to do this, but you do have the capabilities of putting your pencil down there and seeing what happens. Okay, well, let's see. This says decrease the Y-intercept. Does this work if I decrease it, if I move it down? No, that's not going to work very well. So it's not this one. Okay, so the next one this one says increase the Y-intercept only. Let's see, what if I did that? What if I move this up? Does that go through all the points? Nope, still that doesn't do it because that's only increasing the Y-intercept, so that's not going to work. So it's not this one. What do I need to do? It looks like, let's see, first off, I need to move my Y-intercept and I need to increase it. Well, let's see here. This one says increase the Y-intercept. This says increase the Y-intercept. Now, what do I need to do with the slope? Right here, the slope, I need to make the slope get steeper. Be very careful. Now, this is 0, okay? So as I move the line down and make it steeper, even though I'm moving it down, I'm making it steeper. I am actually increasing the slope. The answer should be D. Okay? So let's make a note somewhere on there that when you are making the line steeper, when making the line steeper, what you are doing is increasing the slope. Okay? When making the line flatter, you are decreasing the slope. Okay, you may want to make sure and you have that written down somewhere. Next, Kyla put her data into the calculator and wanted to find the trend line for the data. Okay, she put the parent function in there. Wait a minute, let's go back a second. What is the linear parent function? Linear parent function, you need to have that memorized. That is y equals x. Okay? Now, it wants to know what she needs to do to make her trend line better. Well, let me go in there, and you can use your pencil. And again, I'm going to draw my line up here and see if I can figure it out. First off, it says increase the slope. Increase the slope means to make it steeper. Does that work? Nope, that's not going to work. So it's not A. Well, what if I go here and I decrease the slope? That seems not too bad. All right, let's go back. Let's leave that as an option. This says increase the y-intercept. That means move the y-intercept up. Nope, that's going away from it. So it's not going to be that one. It's not increasing the y-intercept. What if I go here and I decrease the y-intercept? That still doesn't work very well. I think my best option, my best choice right here is to decrease my slope. Next, here's the next one. It says, which of the following best represents the trend line for the data? Well, you can do one of a couple things. You can go through and do delta y over delta x and find your equation. Or, let's go up here and, oh, why is that doing that? Okay. Let's go in our equation, or in our equation, go in our calculator, put in there, let's try the first one. Negative 1x plus 6. And let's press second graph. This says, well, let's just look at the whole numbers first. It says 3 and 5. Up. Well, this one says 3 and 3. Okay, so I know that this is not an answer. Let's try the next one. The next one says negative 1/3 x plus 6. Second graph. I'm not going to mess with the decimals right now. Let's just look for the whole numbers. I've got 3 and 5. Oh, yep, that works. Is there another one? How about 9 and 3? 9 and 3 is there. Okay, now I got to do the decimals. Well, it's the x numbers that are the decimals, so let's go to second window. Let's go to table set. Let's put in there 1.5, second graph, and that says 5.5. Yep. Okay, let's try 4.5. Second window, 4.5, second graph. Says 4. Yep, that works. The last one I need to check is 7.5. Looks like we're on a good roll here, though. Says 3.5. Sure enough, it works. That's my answer. Next one. There's the next one. If you haven't done it yet, pause the video and then come back and see how you did. Okay, so I'm going to go up here. Let's find my calculator. This first one over here, what was that? That was 3x. So let's go in there. Let's put in there. Clear it out, and I'm going to put 3x. Second graph. Oh, I got all these decimals. Don't ever forget, if you do all that, it might be easier just to clear your memory on your calculator. And then go in there and put 3x. Second graph. All right, you got 5 and 15. Yeah, that's on there. What about 2.5? Second window. I guess we could have left those 0.5s. 2.5. Second graph. 7.5. Yep. Let's see about 4.5. 4.5 says 13. Boy, we get lucky. That's our first one off the bat. But you can use the calculator to find your answer. Next, here's the next one. It wants to know what is the slope of the line segment. First off, I know from left to right, my line is going up, so it's positive. Okay, well, all of these are positive. One thing I could do is build a table, and I could put my points in here. 1, 2, 3, 4, 5, 6, 7, 7, negative 7, negative 1, and this one, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6, 4. And you can do delta y over delta x. Remember, delta y over delta x. See, delta y is going to be plus 5. Well, let's see. If I start here, I go up 1, 2, 3, 4, 5. I go up 5. Delta x is going to be plus 13. Well, where'd my pen go here? All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Over 13. Okay, so I have 5 over 13. Oh, there's that answer right there. There's my slope. Next one. Right here. Which is the best interpretation of this graph? If you have not done it, pause the video. If you have, then keep it playing. But if not, pause it and then see if you can figure it out. Well, first off, one of my first points here is my x number is 10, my y number is 1. The next one, 20 and 2. Then 30 and 3. Okay, I'm just kind of looking at some data. It seems like my x numbers are going up by 10, and my y numbers are going up by 1. It says George earns $20 for each hour he worked. Well, okay. This one says for every 10 pieces of candy, she pays $1. Okay. Oh, wait a minute. What am I saying here? George earns $20 per hour. What's happening in 1 hour? They're only getting 10, so it's not A. This one still could work because you could be getting 10 pieces of candy and she pays $1. This one says for every 10 students at the dance, 2 teachers need to be the chaperone. Every 10, oh, there's only got to be 1. Can't be this. The next one says a runner needs to run at a constant rate of 2 miles every 30 minutes. 30 minutes, it's up at 3. Can't be this one. So your answer's got to be B. The next one, it says for a car traveling at a speed of 50 miles per hour, the relationship between the distance traveled, D, and the time traveled is determined by D equals 50t. Which statement is true? Okay, now if we look at all of these statements, they're talking about depends on, depends on, depends on. Okay, what are the 2 things that we're talking about first? We're talking about distance. Oh, let's see if I can get my pen to start writing better now. All right. Maybe not. Distance. And the T is time. Pen is not being friendly right now. Okay, first off, this talks about speed and speed. I'm not talking about speed in here. That's not the 2 variables, so it's not this. Okay, frustrating me with the pen. Those are not right. Now, I know that Y depends on, sorry for the writing, depends on X. Well, what matches up? The Y and the D. So I'm going to have the distance depends on, what's the X? Time. Distance depends on time. My answer should be B. Here's my next one. It says I have a y-intercept of 5 and a slope of 1/2. Normally we have y equals the slope. Again, sorry, I'm having to write with the mouse, and I have it set to right-handed, and I'm left-handed, plus or minus the y-intercept. Okay, the y-intercept, the thing that goes with the x is the slope. So I know I've got to have y equals 1/2 x. Okay? Plus 5 if I write my equation. This says 5x. This is not the right answer. This says 5x. Not right. This is adding my 5 with the x. Not it. Your answer should be A. You can write it like this, or 5 plus 1/2 x.